Okay. So worksheet 4.2, number 6. All right, so number 6 gave us these two shapes. All right, I am definitely giving these to you again. All right, so please make sure you're paying attention to this. So what I highly advise you do when you have a shape within a shape is that you draw the two shapes completely separately. So you can really think about the dimensions of the shape. That's my advice to you. I would highly advise that you draw, first of all, I'm going to draw my given as they gave it to me, and I'm going to label it. Please stop whispering. I know, but I'm helping this. All right, so this is my given. They tell me the top dimension of that big rectangle is 10. They tell me the top dimension of that small rectangle inside there is x. They tell me this little segment right here is 2, and they tell me this longer segment is 4. 2 and 4, oh, 2. 2 is not the side of a full side of a rectangle. Peter, you're paying attention to what I'm doing. Please stop looking at his paper. 2 is not the side of a rectangle. 2 is the part of a side of a rectangle. All right, so we need to use that in concert with another side. All right, so what I'm going to do is I'm going to draw my big rectangle again, and I'm going to draw next to it the little one, not inside of it, because I really want to think about what those dimensions are, because this is the hardest part. Once you do this, the rest of it's easy, because I know you guys understand proportions. All right. What are the dimensions of my small rectangle? Jacob? Yep, x and 4. What's the top dimension of my big rectangle? Kaylee? 10. What is the side dimension of that same rectangle, Peter? That is 6, because it's this entire thing. It's 4 plus 2, which gives me my 6. So now I can go ahead and write my proportions. I'm going to write one using corresponding sides. So I have 10 over x is equal to 6 over 4. And I'm going to put or here. I'm going to write them using sides from the same shape to create our fractions. So 10 over 6 is equal to x over 4. It doesn't matter which one of those two you have. Whichever one of those, like you're like, oh, I totally get that one. Then forget about the other one. All right, I can divide out common factors within the fractions, but because I wrote both, I'm going to go ahead and not divide out common factors, just so you can see they're both the same. So I have 10 times 4 is equal to 6 times x. So I have 40 is equal to 6x. And divide both sides by 6. Divides into it 6 times, that's 36. Keep repeating. So this is going to be x is equal to 6.6 repeating. Or 6 2/3 is what that would be, but 6.6 repeating. Yes, Nick. Yes, so in this proportion, I use my corresponding sides to set up my proportion. So 10 and x are corresponding sides, 6 and 4 are corresponding sides. Or, because some of you do it this way, or I used my shapes to create my fractions. So 10 and 6 are both from the big shape. So I use those in this proportion to create my fraction. So 10 and 6, so 10 over 6. Well, if I do that, then my corresponding sides have to be both be in the numerator or both be in the denominator. If this throws you off, Nick, if this one throws you off, then forget I even said anything to you about it. If you understand this one, then do this one. So and I like using corresponding sides to create my fractions, which is why and that's the normal way to do it, and that's why I teach it that way, okay? Some people see it the other way easier. Whichever way you see it works. Okay? All right. Kaylee, that was 6. Did that help you? Awesome. What else can I do for you guys? Nick. All right, let's take a look at number 11. So number 11 said a blueprint. So the scale of a blueprint was 1 inch to 12 feet. It says the width of a building is 48 feet. What is the width of the building on the blueprint? Okay. So Nick, I'm given a scale. What else am I given? Is that actual or is that the blueprint? So this is our actual. So anytime we're given a scale, we always write our scale as our known fraction. So I'm doing 1 foot, 1 inch over 12 feet. I always put my units on it just so I can see where they line up with. Equals. Well, my 1 inch is from the blueprint in my scale. That 12 feet is our actual from our scale. Remember, your blueprint or your map's always going to have a 1 of whatever you're measuring. All right. Now, my unknown fraction has to be laid out the same way. So my actual has to be in the denominator. My blueprint has to be in the numerator. Well, you already told me I have my actual, so my 48 feet go in the same place as the 12 feet in the denominator. I don't know my blueprint, that's what's missing, so that's going to go in my numerator. So, like the blueprint measures are like our corresponding sides, right? Our actual measures, if we do this like similar triangles, those are our corresponding sides. Does that make sense? Yeah. All right, so now I have 1 times 48 is equal to 12x. I hope you're all looking at your work, not just sitting with your hand on your face. You're sitting up. You're looking at your work to make sure that you're showing this step. All right, so now I have 48 is equal to 12x. Divide both sides by 12, so x is equal to 4. Well, we are looking for the width on the blueprint. The blueprint was in inches, so this is 4 inches. What else can I do for you from the worksheet? Colin? All right, let's take a look at 10. So 10 said Marty has a scale model of a car. So we have a scale model of a car. All right, and the scale is 1 inch to 32 inches. So here they're both in inches. All right, so that can throw us off. But if you remember, a scale model is a smaller model like a blueprint would be. All right, so we know that 1 inch is the model measurement. That 32 inches is the actual. Even though they're the same unit, that is always how it's set up. The 1 inch or the 1 centimeter, that 1 is always your blueprint or your model or your map. The other one is always your actual. So then what they've said to us, if the model is 6.7 inches long, so we have a model length of 6.75 inches. All right, we want to know the actual length. We want to find our actual length. Taking the time to write down your givens and be very specific with your givens is really, really important. Recognizing that this 6.7 inches was your model and not your actual was really important here because they're both in inches. That can throw you off. So make sure you read exactly what that measurement is. So now I'm going to set my scale up. 1 inch over 32 inches is equal to, well, my model is 6.75 inches. I don't know my actual, which is going to be at x inches. So are you cool with that? So now I'm going to do my cross multiplication. I have 1 times x is equal to 32 times 6.75. I'm going to go ahead and do that multiplication. 6.75 times 32. This gives me x is equal to 216 inches is my actual. What else can I do for you guys from the worksheet? Yes? It's not. Thank you for asking me, though. Excellent. All right, how about the book? So page 193. What can I do from page 193? Colin? Yeah. Okay, so 24. If you read the directions for 24, so 24 through 27 use all of the same information. All right, so you needed 24 to be able to do 25, 26, and 27. All right, so what they tell us is, they tell us that we have a 2-inch length on the drawing is 24 feet actually. And 24 said, find the scale. Well, what information do I know about the relationship between a measurement on a drawing and a measurement in real? Dude, it's the only thing on the board. What do I know about a relationship between a measurement in the drawing and an actual measurement? It's like almost the only thing written on this paper. This is the easiest thing I'm going to ask you all day. Sam, what relationship do I know? Be specific, child. 2 inches is equal to 24 feet. So 2 inches over 24 feet. For this to be my scale, what does my numerator have to be? For this to be a scale, what does my numerator have to be? Matthew? A 1. So let's divide out common factors. 2 divides into itself once, 2 divides into 24, 12 times. So our scale is 1 inch over 12 feet. You needed that for the rest of the problems in this part. All right, so let's take a look at 25. Because my guess is somebody has a question on all these. So 25 said, find the actual dimensions of the kitchen. I highly recommend you pay attention to this. Find the actual dimensions of the kitchen. All right, well, if I look at the drawing, my kitchen is 1 inch by 3/4 of an inch. So if I need to find the actual dimensions of the kitchen, what am I going to do? This takes us back to like number 17 from the night before. I know that my scale is 1 inch over 12 feet. What am I going to do? Seriously? You guys have a homework quiz. I guarantee something like this is going to be on your homework quiz. So I need you to think back to number 17 from the day before. If you need to, go back in your homework and look at it. I have blueprint dimensions. The drawing dimensions of my kitchen is 1 inch by 3/4 of an inch. So 1 inch is my length, 3/4 of an inch is my width. What do I need to do? I want to know what these are in actual. What am I going to do? Serena? I'm not converting it to feet. Because that would imply a conversion factor. I'm not converting to feet. Ashton? Don't I need to set up a proportion? Everyone look here at me. When you're given dimensions on a drawing and you're trying to find out what that dimension or dimensions are in actual, You have to set up a proportion for each dimension. Do you guys understand that? If I gave you the dimensions of this room, and I said, using a scale of 1 foot equals 10 feet, 1 inch equals 10 feet, what would the dimensions be on the drawing? You have to find what this dimension would be using a proportion and the scale, and then what that dimension would be using the proportion in the scale. So I need to set up a proportion for each of those dimensions. You're all doing this. This is not an invitation that I need to be giving every day. You're checking number 25. Well, the nice thing is I already know that 1 inch equals 12 feet. So this one I don't even need to do anything for. This one I do. So I have 1 inch over 12 feet equals. I know my drawing measure is 3/4 of an inch. So I have 3/4 of an inch over x feet. Now I do my cross multiplication. I have 1 times x is equal to 12 times 3/4. Well, this is like 12 over 1 times 3/4. I'm dividing out common factors, so I end up with x is equal to 9 feet. So my kitchen is 12 feet by 9 feet. All right, they want us to find the actual dimensions of the dining room for 26. So they want to find the actual dimensions of the dining room. What do I know about our dining room on the drawing? Do I know about the dining room on the drawing? This is actually, oh no, we're not doing that. We want to know the actual width of a door. We want the actual width of the door. What is the drawing measure of a door? Yep. Yes. It's 1/4 of an inch. What am I going to do? Anybody, what am I going to do? I already gave you something up here that you can use as your guide. What am I going to do now? Jacob. No, I'm not going to multiply 1/4 times 12. I'm going to set something up first that justifies why I'm multiplying 1/4 times 12. What am I setting up? Peter, help him out. Yes. Jacob, I have to set a proportion up. I'm not just randomly doing multiplication. That's the whole point of this lesson. You have to set proportions up. Peter, what do I do now? Excellent. X equals 3 feet. So our doorways are 3 feet. You have to set up proportions. This is not conversion factor work. We are setting up proportions using our scale as our known ratio. Okay. 27, I'm not going to give you on a test right now. We can go over 27 another time because you guys have a homework quiz that I need to give you. Nick, what's up? In math, I can when I'm setting a proportion up because I do my cross multiplication. If I was leaving that as an actual number, like that was my answer, no, I would never leave a fraction in a fraction. But in math, when you're actually doing calculations, yes, you can. Okay. So get a piece of paper out. out just in case. What? I gave it to Mrs. Kern, and I gave her a sticky note with everyone's names that gave me money on it. Okay, so she does have it. Okay. Okay.